Good morning, everyone. My name is Sachin, and I'm presenting this assignment, which is a assignment for my course CML661 Solid State Chemistry, which I am submitting to Dr. Pistace P. Thomas. In this assignment, we were given three questions, and we have to answer every single questions via the video. So I have made a combined PPT, and I'll be explaining every single question and answer thoroughly, but in separate videos. So this is for the answer number one for this particular assignment. So we were given some differently shaped sugar crystals because they were sugary because I tasted them. Shouldn't have, but yes, I did taste them. So yeah, that's from the first morphology that we got. Whenever I see the crystals, when I got in my hand, I could see like it was similar to like some hexagonal crystal system, hexagonal type of crystal system. So I used my phone's microscopic camera and clicked a few pictures of it so that I could actually see at different edges and different angles. So these are the four photographs that I have used to figure it out to deduce like what kind of symmetry this particular crystals had. So this is the first photograph which I have taken from the top view of that particular crystal, showing that it has similar to hexagonal morphology, and the hexagon doesn't have the edges of this equal length. We can see this edge length and this edge length, they are not similar. This is also like, it looks similar, but it is not actually similar. I measured it using a scale. And this is from the lateral view or side view of that particular crystal. As you can see, like these dotted lines, you can be able to get to like figure it out, to like visualize like what kind of crystal they are going to form. And these are from different angles and some different lighting as well. So I made a composite of all these 4 or 5 photographs that I have taken and combined them together into one. I draw a particular crystal system, a rough crystal system, using the right hand notations of the particular axis A and B. C axis as unit cell parameters that I have find out. I have measured that A is not equals to B, not equals to C, but the angles are A equals to B, alpha equals to beta equals to 90 degree, but gamma equals not equal to 90 degree. So we just talked about the symmetry elements, talking about the normal symmetry elements and molecular symmetry elements to talk about. Then as we can see, there are three different axes of C2. There's three C2 axes, one from this side, one from this side, and one is from this side. One is from x-axis, one is from y-axis, one is from z-axis, and there's a plane. If you consider this axis as the principal axis, then there is a plane which is perpendicular to the principal axis and giving us the molecular point group as D2H. But we have to deduce the crystallographic point groups from the picture. So what I did it, as we all know that if we have a hexagonal crystal system, we can reduce it down to the 1/3 of that particular crystal system and to get out its the symmetry element. So what I did it actually I reduced this hexagonal crystal system that I got into the 1/3 of its unit cell, which is similar to the monoclinic unit cell actually, where A equals to B equals to A is not equals to B not equals to C, alpha equals to beta equals to 90 degree, gamma is not equals to 90 degree. But here's the thing, in the monoclinic, we have the beta angle non equal to 90 degree, but in this case, gamma is not equal to 90 degree. So it is similar, somewhat similar to the mono, monoclinic unit cells, but it is not exactly the monoclinic unit cell. So as we all know that we have a C2 axis of symmetry which is passing through this particular axis which is harboring the gamma angle, and also have plane group symmetry as well, mirror plane, which is perpendicular to this particular C2 axis. So let's deduce the crystallographic point group for this particular crystal. If we're talking about the whole crystal, as the whole hexagonal crystal system we're talking about, then it has the triple two point group or MMM point group. But if you're talking about the 1/3 of it, then it either have the two, the simple that's the C2 axis is present, and 2 by M as well. We have 2 by M point group symmetry, crystallographic point group for this particular crystal. So this was about the first questions. I have finally deduced the symmetry crystallographic point group for this particular crystal as a whole is triple two or triple M. But if we're talking about the 1/3 of it, which is similar to the monoclinic unit cell that we have, then its symmetry, its crystallographic point group is 2 by M. So thank you so much for listening me, and thank you so much for being with me. Now I will see you in the next video or next part of the assignment.